Hello, my fellow mathematician. Welcome to the study of online differential equation. Today, we are considering the exact equation. So first of all, to solve it, we want to check whether it is exact by doing the following. M of xy is equal to 2xy. This is the function where dx is, and in our case, it is 2xy. Then, we find n of xy, which is the function where dy is, and in our case it is y squared plus x squared. Then the next thing, you get the partial derivative of m with respect to y, and in our case it will give you 2x when you differentiate that partially. Then you get the partial derivative of n with respect to x, and in our case it will give you 2x. Then you check whether partial derivative of m with respect to y is equal to partial derivative of n with respect to x. In our case, it is equal to 2x. That both partial derivative of m with respect to y and the partial derivative of n with respect to x, the result is equal to 2x. So meaning that our given equation is exact. If it is exact now, it means our solution will be of the form f of xy is equal to c, where c is constant, and the total derivative of that function is given by partial of f of x dx plus partial of f of y dy is equal to 0. Then from that now, we compare our partial of f. Our partial of f with respect to x is equal to the part which we are calling m, and our m in that given ODE is 2xy, meaning that partial of f is equal to 2xy partial of x. So you integrate both signs. So integrating both signs, we are going to get our function, which is a function of x and y, which is equal to x squared y plus a function which is a function of y. So that is what we are going to obtain. You can label this equation even you call it equation 1. Then you differentiate partially f with respect to y. That is, we are differentiating equation 1, which will give you x squared plus g prime of y. Then you compare this with what we are given, df of y, which is equal to y squared plus x squared. You compare the two. So the left-hand side of this equation is equal to the left-hand side of this other equation, meaning now we can equate them. We can write x squared of g prime of y is equal to y squared plus x squared. You can see x is both sides and we can cancel it, so that we are going to be left with g prime of y is equal to y squared. Then we integrate both sides. When we integrate g prime, we will be left with g. When we integrate y squared, we will get y cubic over 3 plus constant c. You can call this 2. Then you substitute equation 2 in our equation 1 to obtain our solution, which will be given as f of xy is equal to x squared of y plus y cubic of 3 plus constant c. And if you want to check, you can find the f of x. You can check you are working, which will give you the following. So this will give you 2xy. Then you can find f of y, which will give you x squared plus y squared. And clearly that is what we are given. Then to write it, you are df of dx plus partial of y y is equal to 0. Then we can substitute partial of x with the of f. We can substitute them here. 2xy dx plus x squared plus y squared dy is equal to 0. And this is our given ODE, meaning that our working is correct. Generally speaking, the working of exact differential equation, it is the subtopic which is the easiest when you are dealing with the ordinary differential equation of first order, provided you understand the procedure. The working just flow in a simple method step as we have done here. Or what you want to do, or what you need to do is this to practice. The secret to succeed in mathematics is in just doing the practice, and then once you do the practice, everything else just flow in these simple step methods for you to follow. So thanks so much for taking your time to study with me. If you have not yet subscribed to this channel, kindly consider to do so, because there is much more coming for us as we continue learning. Also, may I get the comment on the comment below so that I can know how to improve, or any other area of mathematics which you want me to tackle, and I will be there to tackle it on your behalf. Thanks so much. More examples, check in my YouTube channel or in the link below.